Okay, so today we'll talk about the SentinelHub API workshop. And then, my name is Boya Zhang. I'm currently a postdoc in UC Merced. And today we will also be supported by Tesfa is here. So he's gonna help me in person, and also Sebastian in FIU gonna help me online. So if you have any questions for the online folks, feel free to type your question on the chat. So Sebastian will be able to help. So the agenda of today, we're in last 10 minutes. So in the beginning, I will introduce you what is SentinelHub API, and I will set the goals for today's workshop. And then we will briefly go through the Python environment installation, which is very important part. I believe most of you have already installed in the Python environment. We're gonna need this for the Jupyter Notebook. And then we will take 15 minutes. So we have in total 6 sections. And the first 3 sections and exercise 1, we will take about 15 minutes. I will give you some time for you to change the code and to customize for your need for getting the data. And then the last 2 sections, and then the final sections. Okay, and the final exercise. So let's start a little bit about the SentinelHub API. So API is a mechanism enabling 2 components to communicate with each other. And for this, we need to use SentinelHub API to communicate with the Copernicus Sentinel, the database, and to getting this multispectral and multi-temporal big data. Sorry, I need to mute. And the users can use API to get very easily to get the data. Later, we're gonna see it. You just specify a AOI, and then you can get the data in a matter of seconds. So SentinelHub supporting.
Re-record.
We are recording, yes. So SentinelHub is supporting different various of data sets, including Sentinel-1 GRD, which is the backscatter amplitude. But today we're gonna focusing on Sentinel-2 data, which is the optical, the level 1C and level 2A. And also it's also supporting Sentinel-3 and 5 and even Landsat. So if you're interested, you can take a look at this document. Current Jupyter Notebook is only supporting the Sentinel-2. So SentinelHub catalog and the process API. So the catalog API, so we're gonna use both of those in the later the hands-on exercise. So catalog enable us to search for different data collections. For example, we can know what's the data are there, like how many images like between these 2 days. And the process API is the one we need to get the data, to request the data, and it's gonna be downloaded as a Python format into our computer, into Jupyter Notebook, and then we can do whatever we want. We can visualize, we can make an NDVI, different composites. And the goal of this workshop is to get you familiar with the SentinelHub Jupyter Notebook, which I sent yesterday. And then you're confident in setting up a Python environment and the basic configurations for the Copernicus the user account. And also confident in using the catalog API to search for the Sentinel-2 data, and using process API to get the data and to visualize. Okay, so that's the introduction. So I believe everyone has this document, which is this document is I sent yesterday for the instruction on the installations. So because we don't have much time, I just talk about several points here. So this is step 2, installation of conduct environment. This is very, very important. So I believe most of you already have this Sentinel environment installed. So we use the command called this, conduct create name Sentinel. So which means we create an environment called Sentinel and including these packages. So this way is it's a very efficient way to make different packages, and they can compatible with each other. The SentinelHub is the main package we need to use for the API. And these 3 are just the fundamental Python packages. S2 Cloudless is for our section 6, which is for cloud masking. So I want to show you another one, which is another document I sent you yesterday. It's called updating environment, which means, for example, in the future, you're already installing your package, your Sentinel environment with these packages. You can always go back into here in the Anaconda PowerShell prompt. You can activate the Sentinel environment, and then you can installing other things. For example, if you haven't installed S2 Cloudless, you can go back to here and then type in this command, and then you can updating your environment, which means it's flexible. It's you can change it in the future. For example, you want to installing GDAL, you can go back here and install GDAL. Okay. So the other thing I want to show you is this IP kernel, which allows your Jupyter notebook connecting with your Python environment. So you can see your environment in the Jupyter notebook. So I also want to show you the final, this step 4, register a Copernicus user account. I believe most of you have already done this. So after you register for user account, you can see here, which is your monthly limitation, which means we only have monthly 30,000 of requests. So it's limited. There are some ways you can get extended. It's called NOR, Network of Research, but I still need to explore it from the Copernicus. And but the good news is like you can use different email address to register different accounts. So you have multiple like 30,000.
Sure.
Oh yeah, or in the lab we can share. Yeah, you can work together. Yeah. Yeah. So you can see now it's only a little bit for me to remaining for this. Okay, so this is my okay. So after this, you can see this is in the Copernicus user platform. You can see this. You create a client ID and a client secret. It's basically user account and password, and then you need it in the Jupyter notebook. Okay, so let's go into the most exciting part, which is the Jupyter notebook itself. I believe everyone have already have this. And then we're gonna go through 6 sections. The first one is just importing packages and basic functions. And second one is we set up basic configuration parameters. The third one is we start using the catalog API to search for the data available. And the next is we request the data and do some basic visualizations. So these 4 sections are the basic ones. They are relatively easier. And section 5 is more complicated. Is to batch download for a given time series. It's automatically download a time series for a given area of interest. And the last one is cloud masking. So I put it at the last for a reason. We're gonna see it later. It's a little bit time consuming. So right now I want everyone to so you can select this block and click run. We'll click run, or there's a keyboard which is enter and shift. You press enter and shift in the same time you run it. And after you're running this, for example, if it's showing this message, which is a warning message, it does not matter. So you successfully installing the package. So let me start from here. So everybody get this block run without error? No error? Okay. Yeah. For the online folks, so did anybody have errors or issues with this block? You can type in the chat. If you have problems, yeah. So let me go through this. So these are basic the Python. Okay, great. So these are basically Python packages. The most important one is SentinelHub, where we can see all of these. We're gonna use those. So these 2 lines are basically authorization. We do not need to dive deep into those. These one are the S2 cloudless. We're gonna need it for the last section. And these are just a function we're gonna use for later to plotting the image. If no errors, you already successfully installing all the packages. And then for the second block, please change your client ID and the client secret with these. Yeah, so I believe you already get the ID and the secret. So you can replace with these two. And then you run this block, you're gonna see something like this. It's simply a returned message from Copernicus platform. So which means you successfully set up your account. So everyone is good here?
I'm sure that the Windows.
Do you have errors?
No error.
Oh, no problem. Okay,
Okay.
no error is good. If you don't have errors, which means you successfully set up everything. Okay. So for the online folks, if you have any questions, feel free to type in the chat. So we're gonna move on with the third one. The third block is we are going to use catalog to search for available images with a time window and AOI. So you can start to run it. Just click it and click this button, run. The catalog is we initiate this catalog object and we give a AOI. So be careful here is south, is the west and the south and the east and north. So it's from the long let, minimum to maximum.
There is possibility to solve like that block
No, it's already fixed. You need to follow this minimum minimum long, minimum let, and maximum long and let. So after that, you give a certain a time window. For example, here we try 6 days in 2018. So here is the search iterator where we are going to search the data. So I comment out this line. Later on, you can play with it. This one is showing the cloud cover. If you only wanted the cloud cover less than 20% percentage, you can use this. But now we want to see all the data available. After this, please run this. It's the results and dates. So does everyone get this message? Yes? Great. So this simply showing us we have 2 returned images. You can see here these 2 images are from the same date, but the difference is they have different tiles. One is SFH, the other is SFJ. So we're gonna play with the tiles later. And also the days. The days, if you run this cell, you can see these 2 days. They are basically the same acquisition time, but slightly different in seconds. Okay. So these 2 are the 2 of the Sentinel-2 level 2A data, which we specified here, level 2A data. Okay, so that's the first 3 sections. If you're already here, which means your catalog API works, and congrats. So the next one is we're gonna start with the process API. The process API, we request the data and we get the data, and then we can do some visualization things. And oops, here I think it's a typo. It should be west, south, and east, north. Sorry. So here I give you another area of interest, which here. And then later on I wanna ask you about where it is. So you can even guess from here, from the lat and long. So it's my favorite place. And then we give a resolution, and then we give a starting date and end date. Okay. So please run it and run the second next cell, which is a very important evaluation script. So in this evaluation script, we can see we ask for the 3 bands, 2, 3, 4, which means yes, RGB, yes. And then we return these 3 bands. You can see the output, we can output the 3 bands. Yes, like at the end, we're gonna request everything.
Oh,
Yeah, all the bands. And here is the request function itself. So in the request function, we need to use this true color script. And then this time we request Sentinel-2 level 1C data. And we specify a time interval, which also is 6 days. Okay. And then we set a response, and then we request this true data. Okay. After this, please run it. You should be able to see the dimension of so this function, so the request data is going to be stored in this variable called true image. And then we can see this have a length of 1, and the dimension is, this is the number of rows, number of columns, and the 3 bands. And then we can visualize this image. Okay. And the image looks like this. So I want to ask, does everyone able to see this image? Yeah. From your laptop. You see it? I see some chats. Yes. Awesome. Yeah. So who can tell me like where it is? Any guess? No. One more?
Okay.
Where?
Okay.
Wait, no.
New York.
No.
China.
Somewhere in China.
I don't know China well enough to know where.
I give you another tip. Look at the Latin long. Again. It's almost the opposite in the other side of the Earth, because you see the longitude is the positive, not negative. California is negative, right?
Yeah.
So have a guess, but it's have similar latitude. Any online folks want to guess?
Taiwan.
It's very close. It's Hong Kong. Yeah, I spent 6 years there. So you see the beautiful ships. So this just showing you can get basically wherever you want and whenever you want. Okay. So I'm gonna show you another example with the process API, and we're gonna go back to our California Yolo bypass. Yolo bypass is a wildlife area with beautiful wetland and crops. So here we specify this AOI, which is in California, near Sacramento. And then we're gonna go through the next block. So in this block, I'm showing you we can actually play with this evaluation script to giving it more bands, and we're gonna calculate a index. The index called automated water extraction index. So with this index, we are able to determining where's flooding, where's not. So it's very useful index. So here we can see to calculate this index, we will need these different bands, these visible bands, and this is the near infrared band B8, and these are the shortwave bands. Huh? Yeah. Yes. Yeah. It's another band. Yeah. Yeah, but I want to tell you here, the bands output 4 does not mean we're gonna output 4 bands, but this we are interested in the time series. So that's why I put like we only output 1 band, which is the index, but we want to have a multiple in time. So here is the main function we calculate. You can see this this function. So later on, I will give you about 5 minutes. You can revise this block and to generate a NDVI for yourself. Okay. So here, request is another request function, and be careful, here is Sentinel-2 level 2A. And then you can just keep everything here, but you can play with here anytime you want. And then, but be careful, if you give a very long, like 1 year, there's a limitation for each request for how many bands can return. So if you give like, I think it's from my experiments, it's only six images. So you don't want to give too long of a time series. And here you see the AOI box we already specified in the previous code. And then this is the requesting data is automatically stored in this variable called the array image. I think that's the power of this API, which means you directly get the data into the Python format. You can do whatever you want with your Python scripts. And these two simply, because from the previous catalog, we already know there are two images, actually two tiles, right? So we're gonna split them into two images, and then please run it and run the next one. You are able to see this dimension is 4, which means you have 4 bands in time. Sure.
Oh. Because you were talking about it taking like an hour if you ask for too many dates.
Right.
You tested this on the cluster or is that on?
I believe it's so Bailey asked a question. So if we put it in the cluster, can we get a more quota, which is not, because I think it's limitation from the Copernicus.
Like they only let you download one at a time, like sequentially, so I couldn't even try and parallelize this, so it does 10 simultaneously.
Right, that what you said is exactly our section 5.
Okay.
So I already make this. So we're gonna go through section 5 later. So you can use my script to download the entire year or even more. So here we can visualize the histogram of this image. We can see this is the array index. And then you can also plot this image. So everybody is able to see this image? Yes? Okay, yes. So I know some of have some errors. We can stop here a little bit. Yes. Okay. So now I want you to doing an exercise. We're gonna spend 5 minutes here. I want you to create a new evaluation script to calculate, instead of the array, but calculate NDVI. Here is the equation. So you can put your code here, which means you can simply copy everything here, right? And you need to change here because we will need only the red band and the near infrared band, right? And also change this equation here to generate your NDVI, and then you can visualize it using this plot functions. Okay. At the same time, if you have any questions for online folks, you can type in the chat, so Sebastian will be able to help you. And then so I and Tesla will help the in-person. Any errors?
Yeah.
So we will come back in 5 minutes, and yeah.
Track of the time.
No,
I'll keep track of the time.
thanks.
This version.
Oh no, we need to use the new one. Yes.
So when I
You're muted. We can't hear anything.
Oh, sorry. Thank you again, Darcy. So let's move on with the last two sections, which is the most exciting part. Section 5 is get Sentinel-2 time series for study area. So in this time, we are interested in a whole period of time, like 1 year or multiple years. So this block is basic configuration. For example, we want the water year from 2018 to 2019. Here I make a half a year from October to March, but you can later on you can make it longer. But let's start from here, the half a year. And then here I specify the full region of Euro bypass. And later on you can test because each request they have actually a limitation on the latitude and longitude. So which means you cannot give a very large area, which means I have to split it into 3 regions. I call it lower, middle, and upper. So later on you can try with the other 2. So here I specify region as 1, which means the lower Euro bypass. You can change to 2 or 3 to see the other 2 areas. So we can only do this patch by patch, okay? And then, so here is the final date, which means we want all the images, Sentinel-2 level 2A images for this half a year. So please run this cell, and then we're gonna move on with this block number 16, which is the actual to getting the data. So here, this one means I already know SEH tile. The tile name is SEH. I don't want this tile. So I want to remove it from my request. So you can see later on, this variable can happen here, which means I exclude this tile. So what I do here is I use a while loop. So I remember we only have a limited request for each, a limited of time series for each request. So which means I make a 10 days as the interval, which means from this half years, I split into multiple of 10 days, and then I make like 10 days after 10 days after 10 days. So each 10 days, I make this catalog API to searching for how many data is available, okay? And then I don't want to dig into the details, but here just I want to get the metadata, the date, and also the tile name. So later on, we can visualize them very easily. And then here is the for loop, which means, so here, this is actually the for loop, we make the request. So here simply means if within 10 days, there's nothing comes back from the catalog, we skip it. And if there's some images come back from the catalog, we use the process API to request it. And then you can see here the time interval, instead of a specified hard coding time, but this time is a variable because we're gonna move on this time from the beginning to the end of this half a year. And then we're gonna actually get this data. It's gonna be stored into Aave image. And here you can pay attention, save data true, which means it's going to be saved in your local machine also. But if you remove the save data true, by default is false. So you won't get the actual raster data. And I can tell you one more thing is the prefix is the directory. For now, you can just make it nothing, which means it's gonna be downloaded data into the same directory with where you have this Python script. But you can specify into anywhere. For our line members, you can even specify into the Pinto. You can be directly downloaded into Pinto or Merced cluster. Yeah. So here, so run it, please. And then if everything's successful, you should be able to see this loop number 0, which means the first 10 days of this data period of time. So the start time is October 1st, and the end time is after 10 days. And we got these 2 images with these 2 tiles. And the last 10 days from the 11th to 21st, there's no image returned, so we're gonna skip it. And for next one is from this 21st to 31st, we have 2 images. So it takes a little bit of time. I think depending on your performance of the computer, it may take like 5 minutes or 4 minutes. And at the end, you should be able to see this. The end time is the one you specified, and later on you can play with it. You can even make it 2024. So you gotta wait for it. It's going to be download everything, all the data, into a variable called I called all data. So the all data is basically 3 dimensions. The first 2 dimensions is the number of rows and columns, and the third one is the time series. Okay. So for the online folks, if you finish this one, please send a OK in the chat. And for here, anybody finishes or still processing? Senior, you finished? Okay, great. So let me see the chat. Still processing but working. Great. Still okay. So if it's processing, and if you take a look at your here, if it's still processing, you should be a asterisk, a symbol here. When it's finished, it's turned back into a number. Okay. Working, but still okay. No worries. It takes time. We can wait a little bit. So later on, you can change, which is you can change the region from 1 to 2 or 3. So you can get different areas of Yodel bypass. You can also change the start and end time. You can get a full like from 2015 up to now. And it's also challenge your computer with your how much memory you have. But you can change these parameters. Even you can change with the tiles, but you need to already have some local knowledge on what tiles you may have. Yeah, and also you can, if you changed here, which means you probably won't have any data, and finished, great. So for the ones who finished, please go back to your folder of your code. You should be able to see a folder called lower, because and in the lower is have multiple of folders. You've opened that folder, you should be able to see you should be able to see the let me connect. Okay, let me show you in my end. Okay. You should be able to see a folder called lower, and in the lower you have all these images with the date and tile, and you click in, and you should be able to see this file name is by the Copernicus, not me. So, and you should be able to see the image itself. Okay. All right. Let's go back. Finished. Great. So we have some folks finished. After you finish this, so we can check what do we get. So there's a variable called CT, which means the count. It's a number of the images we get. We get 18 images from this half a year. And then here, based on this number 18, we set up a 4. So this block gives you some visualization of all of the 18 images we have. And then if it's 18, you can make a 4 or 5, 4 by 5, which is 20. It should be larger than 18. Otherwise, you're gonna have some errors. You can do 5-4, you can do like 3-7, whatever you want. And then we can visualize this.
Sorry, just in case anyone's interested, where we were Monday,
Uh-huh.
Andrew, this is where the marina was.
Uh-huh.
And then we went out here.
Oh.
And this is the area, this used to all be ag fields, the levee field.
Yeah.
This is where we can go, because it was only 1 or 2 feet deep with water.
Yeah.
So that's what it was.
Yeah, Betty talk about in this area, there's crops with water. And actually visibly we can see there's something wrong with the SFH tiles. I can tell you later the reason why, because for this tile, it's very weird because the red, the green and the blue band have values, but the red and the near infrared does not have values. That's why we have weird value of AVE. But at least we have SFJ. In this case, this tile works. But also you can see there's a lot of cloud. Some days can be super, super cloudy.
Cloud filter for
Yes,
this, okay.
that's the last section.
Cool.
And then here you can continue run block number 19 with the same configuration of number of rows and columns. So here you can see the histograms. You can see these problematic images have lots of zeros. So here what I'm showing on the top is the percentage of value zeros, and we want to get rid of them. So I make a variable called flag, which means it's basically 0 and 1. If it's 0, so if it has lots of zeros, I make it 0. And if it does not have much zeros, I call it 1. So I use it to make the filter. So in the next block, I'm going to use this flag as a filtering, and you can continue to run it. So all the ones, so mostly SFH tile is out. Now we only have SFJs, but please be careful. Here we still have the cloud. It's simply filtering based on the histogram of zeros. Okay, we still have half an hour. So here you can, and then you can run block number 21, and then you can see the histograms, which looks much more, which better. But here it still have some issues with SFH. You can play with the threshold to change your criteria. Okay, so if you finish this, please type a finish in the chat. We can, and then we're going to move on with the last section. Finished. Awesome. Okay, so here, and I'm going to tell you why I put it at the last. So last section is the cloud masking. So I know some of you, maybe you haven't installed the S2 Cloudless, which is the official Python package by the Copernicus. If you're familiar with the Google Earth Engine, Google Earth Engine also uses S2 Cloudless for filtering the cloud for Sentinel-2. So here we are going to be careful. This is Sentinel-2 level 1C. So we are going to collect all the bands from level 1C. So this automatically generate an evaluation script. So just run it. You can see the script. We're going to collect the bands from B1 all the way down to B12 and also the data mask. I'm not sure why, because this S2 Cloudless package is only works when you downloaded all the bands. If you download one band, it still does not work. Maybe it's because the algorithm, they need to use all the bands. I don't know. So that's why I put it at the end, because it's gonna be very, very, very challenging on your computer memory. So here obtaining all the bands for one image. Here we're gonna use the process API to get all the bands.
Did you write the ticket saying something about that?
No.
The data.
Yeah, there's might be some.
Yeah, it might be considered it. They might not be able to.
Yeah. So here, if you run it, this block takes some time because you require data for all the bands. But when you finish, you should be able to see this is our ULO bypass areas. We collect 13 bands, and we have a mask. So this really takes time. Please run this block. After you run this, we're gonna go through these 3 command lines, which using the S2 Cloudless algorithm to calculate the cloud mask and cloud probability. So as you run it, I can show you, there's well, chat, everything. I don't know. Okay. So here we can actually, if you take a look at here, I make this date is 2019, March 6th. It's actually one date with very, very cloud, which one from our visualization. So we are downloading for that date all the bands. So if you finish with this, and we can plot it. So here we plot the cloud mask, which is showing the white areas are the clouds, and the dark areas is where we have the data. So there's a lot of cloud in this state. I know you probably still processing, but no worries. I just show you the results. So here, this block 26, which is showing the on the background is a true color image, and the foreground is the cloud itself. You can see this very, very cloudy, but it's successfully detected by this S2 Cloudless package. And the next package in the next block is we take a look at the cloud probability, which means you see the yellowish area, which means very high probability for the cloud, and the greenish, which means have less probability for the cloud. And then you can get a cloud mask, which we can use the cloud mask to masking the data we already required for our time series. Okay, and for this block, I mean, if you have a super computer, you do not need this, because this basically checking for the Jupyter Notebook which variables taking most of the memories. So here, after we run this block, you can see our old data one has a lot of memory. Of course, it's restoring the image time series. And there's also other variables taking a lot of memories. So what we are going to do in the next block is we first, remember we use the flag variable to filter the data, right? We only need the data with less number of zeros. So I used await data to restore the filter data, which is much less than the old data itself. And then you run this command delete. You delete all these variables to make more memories for your computer. Okay, be careful. After you delete it, your old data is gone. And if you want again, you need to rerun the section 5 block, the block, to regain this variable. And after you delete all of these, you can see in this section, I can tell you this block 29 is the most challenging for your computer. We're gonna use the for loop, and for each of the image we want. Oh, the computer only have half an hour, but we are about to finish. So if you use this, everybody please run this for loop. You're gonna see this from 0 to 9, which means we only have 10 qualified images within that half a year. And then it's going to get the data mask for each of the image. And it's going to be restored in this variable called await filter. The await filter filtering the cloud mask. It's going to take about like 8 minutes or 10 or more. Yeah, so I trust you are running this block, and I can show you the result for the final blocks. So this block is we use the data masking, and we masking the await. Oh, sorry, I got some. So this await filter, which means it's still the original the await index, but wherever it's cloud, we masking as 0, which means there's no data for the filtering. Here I replot it. You can see lots of images are totally blank because they are completely filtered by our data masking. So what remains is only especially for this one, you can see this cloud, if you remember. So we only have the remaining areas which have the valid data values. And after this, we are going to take a look at the final block, which is showing you the time series. Now we are confident in what's remaining is already cloud masked out. And then I show you one pixel as example here, maybe somewhere in the crops. And then actually what I'm showing here is whenever there's a 0, which means the time series is 0, I just remove it. And then I make a continuous line with it. And you can see from the beginning of our time window is 2018 October to 2019 March. We can see pretty high await index, which probably meaning it's flooded. But in the March is suddenly a drop of the outlet, which means maybe there's not much water. Yeah, so it's successfully tracking this.
Two things. Maybe I can do this when I start doing my stuff with this code.
Yeah.
There's two things I think we're missing. One is a way to grab the QA/QC and have that plotted, because some of us may be doing error uncertainty estimates. The other one is a little earlier up, like when you make like the cloud mask, but
Yeah.
don't apply it, you could set like to binary it, make it like anything that's over 50% likely cloud.
Yeah.
Make it a 1, because for some instances, like my work, I don't need to have, like if it's that cloudy, I don't even need that image, so I can then change a binary. And then be like, oh, if more than 75 or more than 25% of this whole image is cloud, then then that could clear up some data. But I think those are the only two other scenarios I think that people.
Yeah.
use in this lab. It's
So-
really cool.
Yeah, so the idea of this workshop is to, now we go through all the codes,
Yeah.
so you are able to revise it yourself. Right. Yeah. The QA/QC, we do have a data band called data mask. But it seemed to be like we still need the S2 cloudless package to make it to something meaningful. Yeah, and also it's super flexible. You can change the time interval, you can change the cloud probability for the masking. I believe. So if you have any questions, you can type online, but we are about to finish.
Thank you.
Yeah, and the final exercise is, once you get everything done, you can change your time window for your study area and your area of interest, and you can rerun this, and then to get some results. And please provide your feedback to my email, and yeah, also upload it into GitHub so you can get it from there.
Hey, Paul, I have a question about the S2 cloudless. Thanks for putting this together. This was super informative. But in the cloudless, do you also get cloud shadows or only clouds? Because I know in the Sen2 core, which is the one I use most of the time, it basically gives you the output of the L2As, which has the scene classification layer, and that has has a value for cloud shadows, clouds, cirrus, high
Right,
cloud.
yeah. So I'm not quite sure about the S2 cloudless. From the website, it's just saying the cloud. But I also search for the L2A, the data. Actually, one thing missing from a SentinelHub is there are some bands where we do not have. Like there's a cloud masking band from original Sentinel to L2A, but actually that is missing from the API. Yeah, I need to double check with the S2 cloudless to check if it's cloud or shadow.
Okay, thanks. That was the reason I didn't use it initially, was because it seemed it didn't get the shadows.
Yeah.
Thank you.
Yeah, thank you. Okay, that's it for the workshop. Thank you for your participation. Let me know your feedback or any questions. You can always email me. Okay. Thanks. I will stop right here.